Hi everyone, we're going to be doing some empirical rule examples. So now that we know that different parts of the curve have different amounts of area, because the total area is 1, it also perfectly relates to the amount of data that is underneath those. So we're going to use those cutoffs to help us answer some questions. Let's look at our first distribution. The distribution that we are looking at right now is the male height distribution. And so if you think about that, what that would be is that you would have a whole bunch of males that you would did. Some of them are very short, some of them are very tall, but the majority of them are kind of the same height, right? So it's like lots and lots of data all together. And what we have done is we have simplified all of that data distribution by putting a density curve function on top, and that density curve function so happens to be a normal curve function. So let's get into it. This very first part says, what is the mean height of men? Remember, the mean height is the balancing point of the curve, and for normal curves, that so happens to be right in smack dab in the middle. So my mean is 70 inches. The next thing it asks us to do is figure out the standard deviation. Well, the standard deviation, the cool characteristic about this is we always know there's very little area 3 standard deviations away from the mean. So I would say that there's very little area past 82 inches, and I would say that there's very little area past 58 inches. Besides just being very little area of the curve is also proportional to the amount of data. So there's very few data points past those. Although there are some giants in the world and there are some really short dudes. Proceeding on here, we know from 82 to 70, that range is about 12. And we know that we need to break that up into 3 because there are 3 standard deviations to get to that very point. So 12 divided by 3 is 4, so my standard deviation is 4 inches. Let's put that on here so we can see. So this would be 1 standard deviation away plus 4, 2 standard deviations away, and then 3. So you can kind of see that kind of breakup, and you could do the same thing in the other direction as well. All right, now that we know our attributes of normal curves, let's go and see if we can answer some questions. The first question says, what percent of men would we expect to be between 66 inches and 74 inches? So let's go find 66 inches. Here it is. And let's go find 74 inches. There it is. And we need to know this section right here. How much area is under the curve? Well, if we look here, we know that 1 standard deviation away was at 74, and 1 standard deviation away in the other direction was at 66. And so we can use the empirical rule up atop to say, hey, if I'm 1 standard deviation away on both sides, well, that consists of 0.68 of the area, or 68% of the data. Remember, that comes from up here. All right, so then if I was to write myself a little sentence, I could say, and again, maybe if you need to see it, here's 1 standard deviation away, and here's another standard deviation away. 1 on both sides of the mean, which is right here in the middle. So let's write a sentence. I would say, we would expect about 68% of men to have heights between 66 and 74 inches. Cool, let's do another one. This one, the next one to the right, says what percent of men would we expect to be between 62 and 70 inches? So let's go find 62 inches. Here it is, and 70 inches. So we need to find how much area is underneath of this curve. I'm just going to kind of label that up here. Now, one of the things that I would like to note is how many standard deviations this appears to be away. Notice it's 1 standard deviation away this way, 2 standard deviations away. And if I think back to the empirical rule, we know the empirical rule says when you are 2 standard deviations away on both sides, that consists of 95% of the data. right? That's back here. And because I know that if we needed to take 95 and we only want half of it, well, we could just split that into 2, and we could say that this section is just 0.475% of that area. And again, just in case you didn't quite get that, that is 0.95 divided by 2 is equal to 0.475, because we just wanted half. And so to answer this question, we could say, oops, hello, we would expect about, and we're going to change it to a percent, 47.5% of men to have heights between 62 and 70 inches. Yay! See how the empirical rule helps us to give a quick gut feeling for what's going on with this data distribution. All right, next question. It says, what percent of men are exactly 70 inches tall? So when I look at here and we look at 70 inches, the thing is we can't actually tell how many that is, because a single line has no area. So we would say you can't tell from a density curve. You can't find the area of a line. Remember, the area is proportional to the amount of data, and if I'm looking at a line in itself, well, I can't find the area of a line. So that doesn't quite work. All right, proceeding on, it says, what proportion of men would we expect to be less than 66 inches? So let's go find where 66 inches is. 66 inches. And we want to know what we would expect to be less than that. Okay, again, I would like to use the empirical rule or things to help us. And the empirical rule is always centered from the middle. So if I kind of look at where my mean is and see how far away I am 1 standard deviation away, right from here. And one of the facts that I know about being 1 standard deviation away from the mean is that this space in here takes up 0.68 of the area, or 68% of the data. And so if I wanted to find what was left over out here, we could do that, because we know all of this area needs to add to 1. So in my head, here's my thought process. There's multiple ways to do this. I'm going to say 1 minus 68, because that's what I know from the empirical rule, comes out to be a number that I know, I'm sorry, I'm kind of mentally slow sometimes, is 32. And that would be how much is left over both out on this part and this part all together. But I only want half of that, and so I'm going to take that and divide it by 2 to get me what I want over here. And so that would give me about 16% of the data out there. Oops, I probably shouldn't have drawn that big. I do want to write a sentence. I would say I would expect about 16% of men to be less than 66 inches. It's like a little puzzle almost. But yeah, and we've got one more. Hopefully we're kind of getting the hang of it. This one says, what proportion of men would we expect to be less than or equal to 66 inches? So less than or equal to 66 inches. Well, if we shade it, notice that that's the same exact diagram as we just did over here. And I know the equal to part makes me think like, oh, I must have added something to it. Well, remember, you cannot tell the area of a line this over here also already includes the idea of being 66 or less. Really, those two things end up being exactly the same as each other, this and this. All right, because we can't tell the area of the line, the way that we would shade those look exactly the same. Cool, we'll be practicing how to use the empirical rule in class. It's really helpful to get us quick references for the data to see, hey, what percent of data is in this kind of region. So looking forward to practicing with you guys, and we'll see you tomorrow.